In this video, I'd like to dive into the idea of cofunctions a little more in depth, and we'll do it using, at least for this first pair, we'll use a right triangle. Cosine and sine are cofunctions. Let's use a right triangle to explore their relationship to each other. So let's mark this angle theta. The three angles in a triangle add up to 180. This right angle takes up 90 degrees of that. So this angle here must be 90 degrees minus theta, right? The two acute angles in a right triangle have to add up to 90 degrees, and because of that we call them complementary, right? So let's label some of these sides. Let's just call this the hypotenuse, A and B, right? So as far as theta is concerned, the cosine of theta, the adjacent over the hypotenuse, is B over the hypotenuse there. Well, from the point of view of 90 degrees minus theta, B is the opposite, right? So from the point of view of 90 degrees minus theta, this is the opposite over the hypotenuse. So it's exactly the sine of 90 degrees minus theta. And we could do the same thing showing that the sine of theta is the cosine of 90 degrees minus theta. So in this relationship in a right triangle, or when we're dealing with acute angles, cosine is just the sine of the complement. Right? So the co in complement that shows up in front of sine and cosine is not an accident. It is intentional. Okay. Working through the triangle, we could also show the identities for cosecant and secant, as well as cotangent and tangent, but I'd like to do one of those in a slightly different manner. We are told that cosecant and secant are cofunctions. How might I prove that? Well, I'm going to start with the cosecant, and eventually I want to get this equal to the sine of 90 degrees, I'm sorry, the secant of 90 degrees minus theta. Right? So let's think in terms of sines and cosines. Cosecant of theta is equal to 1 over the sine of theta. Well, sine and cosine are cofunctions, so this is the same thing as 1 over the cosine of 90 degrees minus theta, and that is exactly the secant of 90 degrees minus theta. So we call this proving an identity, right? We proved this identity by starting on the left-hand side and ending at the right-hand side. There will be plenty more identity proofs in our future.